We all know how to add 2 plus 2, right? Start with 2, 3, 4. There are 4. And say you want to add 3 plus 4. What in the world would you find? It's hard to find. So you have to find a car in Minecraft to find it. So where to start next? Now when I turn on the light bulb and turn it on, it's so beautiful. But how do I start fixing redstones to solve math problems? With this! This is either the gateway, or because you can give this input or this input and return the result. But how to solve the problem? Use the gate. A gate is a door that does not allow you to enter. In this case, it changes the signal. If we don't put the door on the door, or if our order gives NOR to the door, we will be nickel. In this case, it changes the signal. Nothing we accept or recommend as a debt. What if I don't open the door to the sea? I understand. Everyone has a preview of the NOR door. But there are no door rules. One way fair. If you think that the gate is illegal, and you don't put the gate in any of the doors, both are good. So I will make another gate. If we all had a gate at the entrance until there were 2 gates for B, instead of B for each door, the police would have nothing. We are sinners in law and conduct. But that's it. Covered with red stones here, it is a mistake to get in the way of the red law and the law to regain power. What will it bring to pursue their achievements now? Meanwhile, MBA. NAND not found. And the doors are easily everywhere. This is different. And here. The Nandoid part is the other part of the NA world. When I go out often, Nand Benacht provides the front door. But we want it to be a final gate. To convert one NAND gate to another, we can simply add a gateway, as there are 2 negative ports. But look where I decided. There is no gate. This gate will not control these 2 gates. What I created here is called the XOR gate. XOR can also be pronounced XOR, but I like EOR. XOR stands for exclusive OR, which means if you include any of them, provides normal or port output. But if I run everything inside, you will see we are not successful. So this is important if the gate. There may be only 1 record during output. You don't if you have 1 or 2 albums. Win. Just enter. Entry people always sit with each other. Provide the entry and exit route to OR gate. At the door, you see fortune tellers handing out a disappearing red stone. Do not turn on the red light when 2 devices are in place. Once burned, this red mineral will not burn and extinguish, allowing the flashlight to burn. This light illuminates the 2 pockets that do not come out, so both exits acquisition is announced. This is important in base 10. Does this mean that before we start pregnant, we start with 0 and go to 9.9 plus 1? It doesn't work, so we have to do 1 through 9 and 9 go back to 0. We always count 11, 12, 13, 14, 15, 16, 17, 18, 19. But how do we add 1 plus 19? We want to load 1, so 19 out of 19 will be 2, 9 out of 0, and we'll keep going. Finally, we get to 99. But how do we add 1 to 99? We can't move to the 10th place because it's already 9. So we have to raise it to 100, and 9 is also 0. We read the same binary value. If there are only zeros and 1s, 0 plus 1 is simple. So 1. But how do we add 1 to 1? You will get 1 minus 10. Sit down, or in this case, instead of 2 seconds, and open it. 1 at position 1 is greater than 0. So we add another 1. We get 11. But now we want to add more. How do we do it? Well, like counting them to hundreds, we'll walk again and add 1 to that, cents. Or, at this point, they have 4p, and again we play about 2 ones at 0. In banner adds, only the last 2 are added to each decimal place. The number 1 may represent 1. The next position is 1 times 2. That is 2. So 1 is the same in this equation. Equal to 4 and will last forever. 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. So you can just add the whole place. So 0 in the 1's position, 1 in the 2nd position, 0 in the 4th position, and 1 in the 8th position. 2 plus 8, which of the 10? So 1010 has 10 binaries. To add 1, it is 11. Or 1011. Add another to get 1100.0. Instead of 1, 0 in 2 places, 0 in 4 places, and 1 in 8 places. The value of 4 plus 8 is 12, so we know for 11 plus 1 equals 12. This XOR gate shows how 1 plus 1 is 0. But how can 1 get into the 2's space? If we place a redstone lantern here, after we both build it, this redstone torch will burn. If we now put it on the second output, we now see 2 instead of lights, 1 instead of 2 seconds, 0 inches. First place, this number is 2, which means 1 plus 1 and 2. Now we need more XOR ports in order to merge more and more numbers. Be sure not to cut redstones between attachments. If you place a block here, it will even appear if they are close. I will color everything blue and green so we will know what numbers are. As a rule, inches. This device will give numbers in blue and numbers in green. Now I have 2 additions. But wait, how can I put a number instead of 2? We need a second set of XOR ports. To these XOR ports will be added the answer provided by the first XOR port with the number moved to this space. Now let me see if the second XOR gate should behave in the same way we should see in the first XOR gate should behave. In this case, we follow the same thread. Like the first, the XOR gate should be removed, but not the second one. And if the second one costs, the first one should not be. That way you don't have to worry about losing behavioral data. Now if you add red light bricks to each of the inputs, you can split the inputs to find out which numbers are adding and perhaps name them to make it easier. This one is Jeffrey, this one is George. It's a fully functional plugin! You can add 2 numbers and the sum is correct. If you want to remove it, you can add the XOR gates to one of the numbers you added. Make a donation you can make. This is how the not blocked port is changed. If you include one side of each door in the XOR, the result will be opposite the one you entered. Now if you put an XOR gate containing a solution on one input, and then turn the handle on the other input, turn it on, and you will get the answer. Let's take a look at a 4-bit calculator. We want 1 out of 2, so we put 1 here, and we turn 2. Now we add 13 to 1, and that is 14. It is 14, 1, 0, and 1, 0, 0, 0, 1. All zeros are absolutely necessary. First meeting, so we moved the answer and found 0, 0, 1, 0 minus 0, 0, 0, 1 equals 0, 0, 0, 1. Here is the whole writing process. 0, 0, 1, 0 goes into 1, 1, 0, 1. 1, 1, 0, 1 plus 0, 0, 0, 1 equals 1, 1, 1, 0. 1, 1, 1, 0 goes into 0, 0, 0, 1. But not 0, 1, 0, 0 goes into 1, 0, 1, 1. 1, 0, 1, 1 plus 0, 0, 0, 1 equals 1, 1, 0, 0. 1, 1, 0, 0, 0, 0, 1, 1. By moving a few levers, you can easily unlock 3 plus 4. At the moment, I don't know a good way to go back and list the base 10 binaries, but I'll do the tests, and if I can, Fun way to do it. You can expect me to make a video about this. So log in, speak your mind, and comment on your comments. Let me know if I'm missing anything or anything else you would like to do. Kita! Have fun with your redstone calculators, experiment, and make shoes with them.